Hello everyone. Today we're going to be talking about IVs, and we're going to be using dimensional analysis to calculate some of the IV information that we need. So we're starting out by needing to hang a manual gravity IV fluid drip. First of all, I wanted to just say that we need to check our 6 rights before we do anything with IVs. We need to remember that IVs are considered medications. So we check the IV site for any untoward signs and symptoms. We check the flow rate. We check drops per minute, mils per hour, and we compare that flow rate with the markings on the time tape. So for today, we have a problem where we have a provider who has ordered 1,000 milliliters of Ringer's lactate, RL Ringer's lactate, to infuse at 110 milliliters per hour. The tubing drop factor is 15 drops per milliliter, and our current time is 16:30. We're going to round to the nearest drop and the nearest minute. We check the IV every hour or more frequently if the IV that we're infusing is a vesicant, even when we are using an electronic infusion pump, because an IV rate can vary significantly due to positioning and, of course, many other factors. We time tape the IV bag, and this is standard practice even with a pump. Well, why do we have to time tape? That's a part of our order here. Why do we have to time tape a pump? Because pumps are not 100% trustworthy, and there's a risk for significant human and mechanical failures with very dire circumstances. So some facilities, when we talk about infusion and completion time and IV taping our bag, some facilities have the nurse document every hour on the electronic medical record or the IV flow record, and some even have the nurse initial every hour on the time tape. So today we need to calculate, we need to find our mils per hour, which is already given to us, which is 110 milliliters per hour. So we have 110. Drops per minute we will calculate using dimensional analysis. And we'll start out with our units of measure, which is drops per minute. That's our unit of measure equals, drops will go into that numerator of that first fraction. And by the way, these aren't pure true fractions. These are simply relationships. So thinking relationships, and we know drops is going to be here. What do we have in the problem with drops? Well, we have 15 drops is 1 milliliter. We're not done yet, are we? We're going to put our multiplication sign. Milliliters climbs up, so we have milliliters. And in that milliliter, we put in 110. And we know this because we have a given quantity of 110 milliliters per hour. So 110 milliliters in 1 hour. And we climb up with hours. What do we have with hours? Well, we need to put in a conversion factor. So 1 hour is 60 minutes. Because remember, our unit of measure here is drops per minute, so we need minutes. Now, are we ready to calculate? Yeah, mils can cancel, hours cancel. All we have left is minutes and drops. That's our unit of measure. And we will multiply the numerators together, and we end up with 1650. Multiply our denominators, 1 times 1 times 60, which is 60. That comes out to 27.5. 27.5, and we are told to round to the nearest drop, so we're going to go to 28 drops per minute. And we can put that in, 28 drops per minute. And the next thing we need to calculate is our infusion time. So we're going to write this in as infusion time hours. Okay, so hours equals, and our hour will go into that first numerator. So what do we have with hours? Well, we have 1 hour is 110 milliliters. Okay, milliliters is going to climb up. What do we have with milliliters? We have 1,000 milliliters, because that's how much we need to infuse. So 1,000 milliliters over placeholder, and we multiply that, so we're ready. Okay, mils, we'll cross out. All we have left is hours. That's what we're trying to find. We're ready. 1 times 1,000 is 1,000. Over 110, and we end up with 9.09, repeating 9.09 hours. And it's very important you understand this is 9.09 hours, not 9 hours and 9 minutes. This is 0.09 hours, and we need to find out what is this in minutes. What's 0.09 in minutes? And what we will have there is to simply multiply 0.09 times 60, and we will get our minutes that way. Or we can do a dimensional analysis calculation where we have infusion time, minutes, equals. So we're doing minutes. Minutes is here. And we have to put in a conversion factor where 60 minutes is 1 hour, and climb up with our 0.09 hours, and we can calculate hours. We can cancel our hours. 60 times 0.09, because we're ready to calculate, and that ends up to be 60 times 0.09, which comes to 5.4 over 1, 5.4 minutes. And we are told to round to the nearest minute, so we will round to 5 minutes. That makes our time at 9 hours and 5 minutes. So 9 hours and 5 minutes, and that's infusion time, and that is how long it will take to infuse this fluid. The next thing we calculate is completion time. And completion time, we simply we take our current time and add our current time to the infusion time. So our current time, we know in the problem, is 1630. So our current time is 1630 plus the 9 hours and 5 minutes. So 1630 is our current time, and I strongly encourage you to separate your minutes and hours when you're doing this. So hours here and minutes. And 1630 plus our 9 hours and 5 minutes. So let's add the minutes together first, and we have 30 plus 05, which is 35 minutes. And 16 plus 9 is 25, isn't it? So 25, 35, but there is no such thing as a 25, 35, because military time, we only go to 24 hours. So in order to convert this into the next day, we're going to subtract 24 here, carry this down, our 35, subtract 25 from 24, and this means that we are in a new day. This minus 24 will bring us to the next day, and it ends up with 0135. 0135 is our completion time. 0135 on the next day. So now we have to think about time taping. We're time taping, and the process of time taping an IV. Yes, you sure can use a piece of tape and write the information on a piece of tape. You also can use something like this. You can use a pre-prepared time tape apparatus like this. And one of the good reasons, in fact, there's several good reasons for using a pre-printed time tape, like this happens to be from Flowmaster. There's several good reasons to use this, and one is that it just looks better. It just looks much nicer. Also, safety, because everything that's important that you need to document is asked for on this tape. So it's all there, and that means you're not going to forget something important on this. It is standardized so that there is no question where to look to find the important information for anyone who is looking at that IV. And it saves time. And let me tell you why it saves time. It saves time in a number of ways. First, you don't have to write all this. Second, you have what is on this particular one, which I like. You have a flow rate in hours, 6, 8, 10, and 12. And all the markings are there for that. So if we have an IV, that's 1,000 mils, and we are at a 6-hour rate. So in 6 hours, this IV will have infused. Here are my marks. So I simply follow this. It's very nice because a 6-hour rate means there's about 167 milliliters that will infuse every hour. An 8-hour rate, here are the markings for the 8-hour rate, and that's 125 mils an hour. A 10-hour rate is, of course, 100 mils an hour. And a 12-hour rate is 83 1/3 mils an hour. And here's your 12-hour rate. Here's the marking. So it really does save time. And it's nice because you have the information. Medications you're adding, the bottle number, the name, your name here, which would be probably your initials, the patient's name. But the bottle number would refer to, say for example, you had an order where you had 1,000 milliliters Ringer's lactate times 3. So that would be 3 bottles. What bottle number is this? It might be 1, it might be 2, it might be 3. Okay, the solution, and very importantly, the drips per minute that you have, the drip rate that you're going to be marking. So up here you would have the start time. Down here you would have the end time. Very nice. And on your IV bag, here's a picture of an IV bag. You would place this at the 1. So here's a nice arrow, and it shows you here's the arrow for the 100, which would be placed at the 1. And on this particular bag, now some bags will start with a 0. This one starts with a 1, which means that at this point, your fluid would be 100 milliliters had infused. Here's 200 mils infused. Here's 300 mils infused, 400 mils infused, and so on down. Now remember, these IV bags are very, very flexible, and that's good to know. But okay, so when you're time taping this IV, let's look at how to do that. We know that, and our order shows that we have, our current time is 16:30. We're infusing at 110 milliliters per hour, 110 milliliters per hour. We would start by using lined paper. And this is kind of my system, and it works real well when you're busy and there's a lot of other things that you need to do. And I just make a line down and across, and I put milliliters infused and time. So milliliters infused, we would start with 0, which of course would be 16:30. And then our first hour, and I would document this by hour, our first hour we would have 110 milliliters infused, and then we would add 110 plus 110, which is 220. So we would have 220, which would be our next, and then just use your calculator and add another 110, and we have 330, and then 440, and then 550, And I'm just using my calculator and adding 110 each time, and 660, and then 770, and then 880. It's pretty self-explanatory here, and then 990 and 1,000. Now it's important to look at this and know that there's only 10 milliliters difference from here to here. If our start time is 0 milliliters infused and it is 1630, which is our current time, then all you would need to do is put in your hours. So 1630, 1730, 1830, 1930, 2030, 2130, and just go on down and mark it. And now we have a new day from 2330, and remember, we don't have 2430. We have a new day that would be marked at 0030, and then 0130, and here is our 10 milliliters. Remember, there's only 10 milliliters, it's not 100. So we have a very short period of time. Remember, it was 5 minutes because we had 9 hours and 5 minutes for our infusion time. 5 minutes, and that means we are at 0135. And then hourly increments throughout. So we can go back and look at our milliliters infused column. We have 0, 110, 220. So every 110 milliliters is an additional hour. When we do our time taping, and by the way, all of this, it's very important you know that these are estimates, estimate times. So these are estimates. We document on our time tape the 1630, which is our start time, the 0135, which is our end time or completion time, and I have it here on the document, and that we are at 28 drops per minute. So we're at 28 drops per minute. And then as we document with our Sharpie, it's going to be every 110 milliliters. And it will take 9 hours and 5 minutes. So every 110 milliliters, and we can go back to our chart and say, okay, so the first line is going to be 110. This is 100, so we're going to mark approximately 110 and identify that that will be 1730. Another 110, we're at 220, so approximately there, and that's 1830. And then 330 here, let's just say it's a third, 1930 and 2030, and we go down to our 0130, and then 0135, 5 minutes later, we have the end time. And I would definitely circle it on your time tape. And thank you. That's how we do a time tape for a 1,000 milliliter IV. Thanks for watching.